Okay, it looks like my it froze. All right, can you guys hear me now? We had looks like it froze there in the stream, but let me know if you guys can hear me now. Hopefully the audio is back up and working. All right. All right, so okay, audio is good. Thank you, Lyndon. Thank you for pointing that out. Thank you, Tom. All right, thank you guys for letting me know the audio is work. So welcome to Office Hours. A little bit of a snag in the beginning, but I think we are back on pace. Let's see what the things people have been posting. So I see hello, Lyndon. Hello, Anna. Someone saying the OOP notebook. I see the term while declaring an object for a specific class. Can you explain why we have a numerical number 2 here? My class 2. All right, so someone's saying, can you explain this line? Which says my class equals my class 2. Yep, put that on the agenda. Someone's saying Jupyter Notebook. No nodes available, 0 out of 114. Is there an ongoing issue with the nodes? And I'm not having any trouble, although I'm kind of curious if anyone out there right now in Office Hours is having trouble currently accessing the pod. Do let us know. I'm kind of curious to see if anyone else is having your issue, Vivek. All right, let's see. Okay, so let's take a look at this specific question before we dive into the VC mini project and additional topics. I think I'm getting blurred out here. I think my stream is blurring. In fact, let me go ahead and connect myself directly via an Ethernet cable. That might improve some of these issues. Hold on. All right, so let's go back where we were. So it looks like someone's asking about something specific about the OOP notebooks. Let's open that up and explain that, answer that question. Okay. A little slow on my end. Let's go ahead and load that up. All right, so let's look for my class. Do Control F search. My class. All right. So what you want to do when you look at a class definition, screen is blurred. Can someone remind me how to set the resolution? All right, someone can help out Tom. I know I hit refresh on my tab because I have two screens where I see my feed. And I hit refresh and that fixed some of the blurry issues. But if someone can help out Tom about setting the resolution, that would be great. All right, so let's look at this class definition. So we define a custom class. We call it my class. And notice we have the init method here, the dunder init dunder. This right here specifies what are the attributes that are assigned to an object when we create it. Think of it as the initial kit of data your object has once you create the object from this class. The first argument is self, which is the object itself, and there is a second argument called num. And what we do is we assign our object, which has the name self here, we create an attribute called num that is equal to whatever the user passed when they created the object of that class. So this init method here is called the initialization method. It defines what does the object have once you create it from the class. So if we look right here, we say my class 2, so that means num is equal to 2. So that means that our object will have an attribute called num equal to 2. And then since we call the doIt method, what does the doIt method do? Well, it prints out the attribute called num. So it should print out 2. So notice here we are calling the method from the object. We can also call it through the class. If we call it through the class, then we have to provide what is self. Since we called this method from the object, it knows what self is. It knows what is the first argument to this method. But if we call it directly through the class, then we got to provide what is self. What is that object? So do let me know if that clarifies your point. Okay, so do let me know if that clarifies your point. In the meantime, let's go back to, but why are we using numeric 2 within my class? Okay, why are we using numeric 2 within my class? In other words, why we have it written out like this. So what this here means is we are calling the init method with num equals 2. Notice here we have the class and we're calling the class. It's sort of like we're using it as a function. When we do this here, what that means is we're creating an object of that class. So in other words, I can say my class, I can say my class, I say 3. So what that means is that the object is that we are calling the init method, the initialization method, which means create an object of that class. And self refers to the object itself. And maybe the best way to explain this, maybe if there's the best way to explain this, is if I create a very bare bones object. Create a new class, my class, object, and there's nothing to it. There's nothing to it. Say my class equals my class. And notice the init method, there is no init method. So when I create an object from this class, I don't pass any data to it. But if I want my object to have data, then I say my class dot num equals 3. So here I create my object has an attribute called num with the value of 3. But it'd be very nice that I can do this at the point of creation. I want to define my object to have an attribute called num equal to some value. In order to do that, I need to define the initialization method. What are the attributes? What are the data that are defined when I create an object from that class? So then I say class, my class, object, and I define the init method. And the first argument of the init method is the object itself. And then any other attributes you want to assign to the object. And then, yep, I think you're getting the point here, but I'll just, and since the object itself, since the object is called self, self.num equals num. It's like if basically what I did right here, but it's contained in the initialization method. So that means when I created the object from that class, I assign a attribute called num given this argument here. All right, hopefully that clarified things. Let me look at the chat. Yeah, so Subhan, so self is the object itself. So this is equivalent to saying my class dot num equals 3 or equals num. You're going to use this as a placeholder for the object's name. So then in a method we want to make use of that num attribute, we have to say self.num. Someone is saying, is there any advantages in calling the object through the class? And there really is no advantages, to be honest with you. There really is no advantages. Just two different ways to go about it. I think this here is better. I think it's a little more readable. So there really is no advantage. All right. In other words, if you were to time them, they take the same amount of time. And is there any cases where one would have to be used over the other? I can't think of it at the top of my head. So you can think of this as just a shorthand for doing this here. Sort of a nice convenience. All right, let's take a look at more stuff that's going on in the chat. All right, looks like we got the RDX. We got your issue resolved. Someone is asking, are you on Kaggle? And the answer is no, I am not on Kaggle. Someone is saying, why do we have an object in brackets in my class object? Also, do we not need class self object? So where is, you say, why do we have object in brackets? In other words, why? What does this mean here? What does this mean there? Let me know if that's your question. All right. First line. Yep. What does this mean here? So, what this means here is you can think of that there is object and attribute. Object is a class. It's a bit confusing. But here is we're telling Python that we're creating a custom object from scratch, or from a very bare bones template. We're creating a very bare bones template. And if we want to create an object from a very bare bones template, we say object. Alternatively, we could have used this instead. We could say my class we could have done this as well. They're equivalent. Here, it's what we're trying to signify here is that this custom class is going to inherit from a very bare bones basic class in Python. And but these two things are equivalent. This here, when we go on to inheritance, when we want to build a class from another class, then we will replace object with whatever class we are inheriting from. Okay. Is object an attribute? An attribute can be an object, right? An attribute can be an object, but you can sort of separate those two things. You can think of an object as an entity. As an entity. You can think of an object as some sort of entity. And that entity has data called attributes. But it also has tools, which are called methods, that can work on that data. These attributes can be other objects. There's no restriction. The attributes can be other objects. Right? So if this here has a wrench, well, the wrench is an object. And the wrench has its own methods, possibly. All right, so I see under the algorithms notebook, let's see. Let's take a look at the chat. Someone's saying, if we don't give a number, will we cause an error? Yeah, that will cause an error. In fact, let's just prove it, right? Let's cause that error. Get a type error. So in other words, notice when I didn't specify the num, it complained saying, hey, I need something else. missing one required positional argument num. So yes, you need to specify what that num is. All right, there's some questions about this time it, and I think I'll just put that here formally on the agenda, discussion about time it, since it's used a lot, quite often, in their notebooks. Now, we have not covered this formally in office hours, so I'll just put that on the agenda formally. So since we had an introduction to object-oriented programming with this question here, let's dive into the VC mini project once again. Let's dive into that. And we left off yesterday, if you did attend office hours yesterday, we had a discussion about private and public classes. If you're coming from other programming languages, they make a distinction of a private method and a public method. And what these are, essentially, is there are methods that the user, the creator of the class wants people to use. Those are public methods. Think of this as if it were a museum with interactive exhibits. Those are public methods. Those are methods that the public can go into the museum and play with. However, there might be methods that the creator defined that are private, that they shouldn't be used by anyone else. They should only be used internally in the class definition. This is where if I go to a museum and I see a door that says employees only, and I were to go in there and start playing around with things, that's not intended. Those are private methods. The user should not mess around with those private methods. As I said before, some programming languages make a very sharp distinction between private and public. Python gives you a little more freedom. There really are no private or public methods. However, in Python, if you want to signify that a method is private that the user shouldn't use directly, you name those methods with an underscore. You name them with an underscore, and hopefully that will scare off the user saying you should not use that directly. That should only be used internally. Employees only. And if you really want to make a private method in Python, I say private in quotes since there is no distinction, then you name your method with 2 underscores. You can still, anyone can still call this method. However, they have to type a little more code. In order to call this method, they have to say underscore the name of the class, then the name of the method. So it's a little longer to write out. So hopefully they get the message saying, hey, this is a private method. You really shouldn't be using it. If you really want to use it, you have to write out this part there. So when we work on this assignment, when we work on things, if there are methods that we don't want the user to use, then we should use the convention. We'll call that with an underscore. Signify that that is private. It's more of a signal, more of a warning in Python than anything. All right, so we can talk about inheritance. I'll throw that on the agenda, inheritance. Inheritance, and it's often comes up. I'll throw that on the agenda. All right, someone is asking, how is it linked to dunder name dunder? Unrelated. But I think that is on our agenda, the dunder name dunder. So I do plan to talk about that. What about private variables? Is that possible in Python? There are ways to do that in Python. There are ways to define private attributes or semi-private attributes where if someone tried to change them directly, there would be some sort of warning message or some sort of error be raised. So there are ways to go about that in Python. In fact, I can probably throw that on the agenda if that's of interest. Private attributes. Someone is saying if I'm on Kaggle, and the answer is no, I am not on Kaggle. I have some problem with Kaggle is it tends to emphasize predictability. There's a loss of business motivation, and I do plenty of data science, machine learning in the company, so I I don't feel the need to go on Kaggle. But the answer is no. What about the ones with no underscore? Well, if we have a attribute, if we have a method without an underscore, then that just means it's a public method. All right, someone's saying, where can I see works on data science? Well, some of that is done internally in the company, so I cannot, it's sort of a trade secret, so I can't necessarily expose you guys to some of that work since it's inside the company. Yeah, so the ones that don't have underscores, those are your regular methods, public. Now, those that have double underscore, a name and double underscore, those are special methods. Those are methods that are tied to some special operator. In other words, if you want to use the plus operator in Python, you need to define this dunder add dunder method. If you want to use the minus operator in Python, you need to define the dunder sub dunder method. So this can be kind of confusing, right? So no underscore. Public. One underscore. I'll put private, and I'll put that in quotes. 2 underscore. I'll call this really private. And if we have double underscore method double underscore at the end, then this here is a special method. Something that's called magic. Does every reserved word have a dunder method named dunder? Most do. I think most do, if not all. Most do, if not all. Okay. Let's go and move on, but let's talk about what is going on here. Someone did bring this up, and I will have to mention what is going on here. So notice the grader works 2 ways. You can give the grader some sort of static result, or you can give a grader a function. And the grader will take that function and use it on a set of inputs to test out your function. So if we look at what this function does, it's going to accept an argument called points. It's going to iterate through those points, and appears what's going to do is going to create a list of point objects. And then what it's going to do, it's going to use the reduce method on these list of point objects. If we look at that reduction, what that reduction is doing, it says add x and y, add x and y. So in other words, at this point here, we will have a list, we'll say points. We can create a list of point objects. Just like that. And if we want to add all those point objects, we can use the reduce method. Sorry, the reduce function. So func tools, import reduce. When we say reduce, lambda x and y, lambda. So what this means is that we're going to apply a function that's going to add all those points together. So it's going to add this one with that one. That gets the accumulated result, as we saw yesterday when we were talking about reduce. And that updated accumulator will get added to the next point, and so forth. So x plus y. And then we also do y. So we do this right here. We get a type error because I forgot about points. Notice we sum up all the points. They do it again, but subtract. I gotta sneeze, hold on. Sorry about that. And then it's going to convert what comes out of it into a string. And then it compares that string with our answer. So what it's doing, what it's trying to do there is assess your answer. And someone's saying, let me go ahead and look up something directly. So what we do so what's happening is that what the grader does, it has a list of tuples. It has a list of tuples. For example, it's a very short list of tuples. We'll call this data. We'll call this data here. And we want to create a set of a list of point objects from this data here. So what we will do, we can say points equal, we can say for xy in data. Since data is a list of tuples, so we can say xy unpack those tuples, and we can create our list of points right there. Now, in fact, I will just have points right there, print it out. There it is. We have a list of points. Alternatively, we could have unpacked the tuple directly. So I could have said for datum, which is a singular of data, and said datum star. This is the unpacking operator. We are taking this tuple and we are unpacking into the individual components. So this here, so in other words, points star datum is equivalent to, is the same as point datum 0 and datum 1. This here is the unpacking operator. It takes an iterable and unpacks it into the individual components. So this is a shorthand. So that's what this code is doing right there. So now we get a list of points, and then we proceed to use the reduce function to reduce it down to a single point object. We create the string representation. It does it for subtraction, and then it compares the string with what should be the true answer, and it gives you a grade. So that's what's happening with this function here. Okay. And the lambda, and I explained lambda yesterday in office hours, or yesterday or 2 days ago. Take a look at the office hours there, but I'll quickly explain it here. A lambda is just creating a function for one-time use. We want to create a function of one-time use, and what this function is doing is adding up the accumulator with the next value of our sequence. When we use reduce, you can think of it as it's going through the data structure, adding up the components. So I have, let's say, 1 and 2, and 2 and 3. Oh, I'll just scratch that. 1 and 2, 3, 4, 5. When I say lambda x comma y equals x plus y, I'm defining a function that accepts 2 arguments, and adds up those two arguments. So it's going to do, as I go through reduce, as we saw yesterday in ALPSTARS, 1 plus 2 is 3. Then it says 3 plus 3 is 6. 6 plus 4 equals 10. And finally, 10 plus 5 is 15. So the lambda is creating a function of one-time use. Let me know if there's any follow-ups right here, but I do want to continue on. I see a couple of points in the chat, so I will get to those. But let's talk about multiplying our points. If you see this discussion here, there are several ways what it means to multiply a point object. If I have a point, I say 2 times a point of, let's say, 1 and 2, what that means, I'm going to scale its x and y by this number, by this numeric. So this should equal be a point of 2 and 4. Doesn't have to be an integer, it can be a float. So for example, 1.2 times point should be a new point object of 2.5 and 5. So in other words, when we multiply a number, a numeric, by the point object, we get a new point object where we scale the x and y appropriately. That's what it means to multiply a number with a point object. What about multiplying 2 point objects? In other words, what does it mean to multiply point 1 and 2 and point 3 and 5? Well, we're going to take the dot product. Dot product, sometimes called the scalar product. And the way you define this dot product is you're going to multiply the x here with the x there, and you're going to multiply the y with the y and add up the corresponding result. In other words, you can do 1 times 3 plus 2 times 5. And that here is equal to 13. That's the dot product. That's what it means to multiply 2 points together. In other words, if I write it down another way, it's x1 times x2 plus y1 plus y2. We multiply the corresponding x's and y's of the two objects, of the 2 points, and then we add up those two separate products. And that's what it means to take the dot product to multiply 2 point objects. So let me know if there are any questions about what does it mean to multiply a point with a number, a numeric, and another point object. And let's go ahead and flesh out how we would define that method, those operations. Is dot product also matrix multiplication in NumPy if we have a 2D input? So a dot product is not quote matrix multiplication. However, Python, NumPy does various matrix multiplications. In NumPy, you use the dot method. you use NP dot. That's how you do matrix. It's confusing, but that's how you do matrix. Sorry, let me back up. Let me think about this for a sec. Yes, in order to do the dot product in NumPy, use the dot method, dot function. So A and B. It's also how you do matrix multiplication as well in NumPy. Okay, other questions we will have before we start coding up the solution. And what I'll do, since we need to make use of what we had before, I'm going to copy and paste this. Copy that. I'm going to go ahead and paste it here. A couple of things I want to remove. Let's move some of these comments here. And remove that really private method. Okay, so we want to use the star operator in Python. So in order for us to use the star operator, we need to define the def dunder mul dunder method. So in order to use the star operator, we're going to define this special method, dunder mul dunder, and accepts self and other. So in other words, what this means is self is the one on the left, other is the one on the right when we use a star operator. In other words, if I say point 1 and 2 multiply by point 2 and 3, it's saying self times other. So now that we said, remember we said we're going to do two different things depending on what is other. What are we multiplying it with? So now my question to you is, well, what should we do? What is the logic we should deploy here? I want to do two different things depending on what is other. So generally speaking, what type of methodology, what approach should I take? Yeah, so can I use isInstance and isInstance? Yes, exactly, Naya. That's what we want to do. We want to do a check. So what we want to do is check what is the type of other. And depending on the answer, we're going to do two different things. So we're going to use, yes, the isInstance. Exactly. So we're going to say if isInstance, we say other and integer, then we do the scaling operation we discussed before. So which is return. I'll do this in multiple lines. You can just illustrate it. We can do this all in one line, but I'll just do it in multiple lines. We say x new is self.x times other. And we do y.new underscore new is other times self.y, and we return point x new, y new. We can do something like that. However, this only is going to work when the other is an integer. So I could have a else if here. and just copy this here and change this to float. And while this is perfectly valid, although this is perfectly valid, what is the problem with this here? Any concerns about this approach here? We'll take care of the other case where it's an point. But what is a concern right here? It will work out, but what is if I were to critique my code here? Yeah, we're repeating the same piece of code. And this is not great. So we probably could do, well, the quick fix is realize, and we use isInstance, you can give it more than one class. In other words, if I give it a tuple, I can say int or float. We got to consider the float case. So I can do that all right there. If that wasn't an option, if this was an option for some reason, let's say isInstance only works with if you give it just one class. If that's the case, then I should probably take this functionality and define it as a separate method. Maybe I can do that instead. Right? So when you work on your solutions, when you work on your code, take the moment to reflect back and ask yourself, am I repeating functionality? Can I make this a lot simpler, a lot more streamlined? And here the answer is yes. If I take this code and put it as a separate method that gets invoked appropriately, or realizing that isInstance can work with more than one type and just use a tuple. So, all right. Let me know if there's any questions right now before we move on to what to do if it's of a class point. All right. So now we say, let's look at the other case where we call isInstance, say other is of class point. And if that's the case, then we're going to go ahead and do the dot product that we mentioned before. So if I say self.x times self_other.x plus self.y times other.y, and we return that as our answer. And that should work out. But the other thing that I want to do is, in case someone passes something that isn't a numeric, there's a numeric check, or a object of class point, what I want to do there is I'm going to raise an error. I'm going to raise a value. I'm going to actually raise a type error. So I can define things that raises mistakes, raises errors, and I'm going to raise a type error. And then what I'm going to say here is type error. Let's put a little message saying something like other needs to be a numeric or a point. It is a placeholder, f string, type other. So I don't have to do this. This is optional, but this is great practice. Where let's consider that edge case. We consider the fact that the other is an integer or float, a numeric. If it's a point class. But if it's something else, let's go ahead and raise an error so that the user can know, oh, I made a mistake. This is the problem. Give a little message that's descriptive. Other needs to be a numeric or a point, sorry. It is of type other. So now once we define this method here, I can say PT1 and 2, and PT1 and PT2, say 2 and 3. Let's try that out. So this should be a dot product, should be, if I do my math correctly, should be 9, I believe. 8. Oops, I did my math wrong. 8 right there. If I multiply by 2, that works out. Scale it up properly. 2 and 4. But what if I multiply by a tuple? This should raise a type error. And sure enough, I get the type error that I invoked. Other needs to be a numeric or point. It is of class tuple. All right, any questions people have? All right, I'm going to go ahead and move on. All right, and here it just defines a function that the grader will use to evaluate our class definition. Someone's saying various types of errors. I'll do a quick summary. There is value error. If this you would use if there's something wrong with the data that something that has. So for example, maybe you have a method where you only accept positive values. You might want to raise a value error if it doesn't fit that criteria. There's something wrong with the value. There's type error. Maybe there's something wrong with the type that you gave it. Type error. Let's see if there's any documentation. Inappropriate argument type. Right. Value error. Inappropriate argument value. We can also look at, there's index errors. All right, if there's something sequence index out of range. So we have quite a few. There's name error is another one. Name error is when we are using something that doesn't have a name, hasn't been created. Probably have a typo, or we didn't create it as we thought we did. That's a name error. We're referencing something that doesn't exist. There is no name associated with it. Is there a link we can use? And I can probably find something on there online that has a good resource. I'll have to get back to you on that. Raise is a type of kind of exception. No, raise is not a type of exception. Raise is the mechanism where you can raise an error. So that's what raise means here. It says, hey, raise this problem. You can think of it Python saying, hey guys, stop the process. There's a type error. Let's raise it up. Let's raise it up, wave a flag saying, hey, we have a type error, stop the process. Yeah, so there's a shortcut we could also, and this becomes a little more important, we can do raise, we can do shift tab. Let's see, any documentation. That doesn't have any documentation there. Type error, Shift Tab. You can look up the documentation. We'll do this a lot when we do with pandas. We will do Shift Tab to look at the documentation, or have a question mark and run the cell. So Shift Tab. Shift Tab again gives you a little more description if there is more. And Shift Tab 4 times in a row pops up this little window. All right, so what is the difference between raise and assert? So raise causes an error. Assert is a check. So in other words, assert that 5 equals 6. Well, this is going to cause an assertion error because this isn't true. So assert checks whether what follows is true. Assert equal 5, nothing happens because there was no error. So assert raises an error, an assertion error, if whatever it follows isn't true. All right, so let's examine this distance operation. So we want to define a method that can give us the distances between 2 points. So let's say we have in our coordinate system, we have a point right there and a point right there. To figure out the distance is this length here. And the way we do that, the formula for that, is we're going to subtract the x's and the y's, square them, and then sum them up. Basically apply Pythagorean theorem. The Pythagorean theorem says c squared is a squared plus b squared. You can think that this is a, this is b, and this is c. Where a is equal to x1 minus x2, b is equal to y1 minus y2. So in other words, if we want to find the distance between 2 points, we will find the difference in their x components, the difference in their y components, square them, add them up, and take the square root. Because that distance, I'll call it d, is a square root of x1 minus x2 squared plus y1 minus y2 squared. That's how we calculate the distance between 2 points. Let me know if there's any follow-ups right here in this equation. All right, so let's code this up. So in this here, we have to subtract our point objects. We look at this here, we have to do this operation. And now let's keep this principle of dry. Do not repeat yourself. And whatever we define, we got to make sure that we're not repeating ourselves. I'm going to go ahead and copy this here and paste it right there. Just erase some of these checks here. Let's define this distance method. And since it's a public method, it's not a special method. It's just distance, right? There's no underscores or anything like that. Can we discuss time it? Yeah, we can discuss time it, but I have to reserve that for tomorrow, unfortunately. All right, running out of time for time it, I guess. So we define our dist method, so self and other. And the first thing we want to do is we want to subtract. We're going to find these. If I sketch it out, where did I have it? Find these distances there. sorry, not these distances. Find those differences between x1 and x2 and y1 and y2. What do your people suggest the best way to go about doing this? Keeping the principle of dry. Any suggestions on what we should do? So I can say x diff, I could do this. I could do this. I could do that, right? But we already captured this functionality before. Yeah, so as I see that Kinjal expressed, we've done the subtraction before, right? We've done this subtraction before. Hello, Kinja. We've done this before, right? So we could do this, but we're going to repeat ourselves. Why not invoke what we already defined before? So what do you suggest we do? What should we replace this with? What are your suggestions? Given our discussion right now, how should we replace this block of code so we're not repeating ourselves? How do we replace this block? Yeah, self.other, exactly. So I can say diff is self minus other. Yeah, exactly, right? That's exactly what we need to do. So then now we can say return, we can say diff x square that plus diff other square that. Yeah, self.dunder sub would have worked as well. Yes, this, we could have done that as well. Perfectly fine. Same thing. We could have done that as well. Exactly. Thank you, Naya. And then we take, this creates the differences. So I can call the x difference, call the y difference, oops, diff.y, square them, add them up, and return the square root. So now my distance function is very compact. So now if there's a problem, right, I'm reducing down the duplication of my code. Compute functions explained under the Gaussian notebook PY algorithm. All right, thank you, RDX. I will probably explain time it tomorrow since we are out of time, but I will make sure I put that on the agenda as we go forward. I do have to play a bit of a prioritizing, what should I focus on and what should I talk about in office hours, but I do keep track of these things. All right, thank you. All right, guys. Bit rushed at the end, but I think we're making progress on object-oriented programming. Anything quick before we wrap it up? The lesson today was you could write out your first solution to your code, but take the moment to reflect and ask yourself, can I do this a lot simpler? Can I prevent repeating myself? Can I use what I already built before? Right? You're not paid by the number of lines of code, right? So let's go ahead and write code that's maintainable and is readable. With that said, guys, take care and see you tomorrow.